Hello everyone, welcome to RX2010's Week 5 presentation. This week on the presentation we are going to focus on wrapping up everything you've learned about calculations to date in this course. However, just a note that this week's test will be much like the test in Week 3, where you will have about 10 questions that were open-ended calculations questions. And then the rest of the material for the test will focus on the reading materials that you had for this week out of the book. You can also go to the student materials section in the classroom and click on this week's blog to find the study guide for the test for this week, which will give you some helpful hints on how to prepare, how to get those, how to use those tables and things, much like you did for Week 3. However, like I said, we're going to focus on the calculations just to wrap things up for these 5 weeks. Make sure you're keeping all of these presentations handy, as well as any of the notes that I've sent to you or that are in the student study materials section as well, because you will see all of these calculations problems again in the upcoming courses. So let's get started. First, we're going to talk one more time about dilutions and allegations. Dilutions and allegations are very similar, and we can use the grid to solve both types of problems. The big difference being a dilution is where you take one substance and you make it weaker by mixing it with a water or some other base. That water or some other base is going to be represented by the strength 0, so 0%. An allegation is when you are taking two things of different strengths, but the same drug content, and you're making something in the middle. So the strength that you're making has to be in the middle in order for it to be considered an allegation. So let's take a look at an example. We have a prescription for silver nitrate, 0.25% solution, and we're wanting to make 1 liter of it. So 1 liter is the amount we are trying to create, the amount we're wanting to take, or make, I should say. Hang on one second, I'll get my pen ready for me. We have in stock, so this means when we go to our cabinet, refrigerator, wherever this particular solution is, we have in stock 1 gallon of silver nitrate, 1%. Now the fact that we have a gallon is great to know, but it's not going to necessarily be used in this particular problem. It just means that that's how much we have available if we need it. We are wanting to make 1 liter though. So we're wanting to make 1 liter of the 0.25%. And we want to use the 1% and we want to use distilled water. Since we are using distilled water, this is a dilution problem, and that third percent that we need is going to be 0. So we're putting these into the grid. The strength we need goes in the center, so we're wanting to make the 0.25, so that's what went in the middle. And we are using 1% and a 0%. Our next step is to do our subtraction. So 1 minus 0.25 is 0.75. 0 from 0.25 is 0.25. Remember, we need to know the total number of parts, so we're going to add these two items together. So 0.25 plus 0.75 is going to be just 1 whole. And then we are going to use those parts and we're going to write our two fractions. So this 0.25 is going to go on top, and then 1 whole on the bottom. And then we do the same thing with the other one, 0.75 over 1 whole. Next, we're going to multiply by the quantity we want to produce. And for this problem, remember, we were wanting to produce 1 liter. We want to change that to milliliters because our final answer is asking us how many milliliters do we need. So I changed 1 liter to 1,000 milliliters, and I multiplied both of those fractions by 1,000. When I did that, I found that I needed 250 milliliters of the 1%. Remember, we're reading across, so it's 1%. And we need 750 milliliters of the distilled water. So that's how we determine how much we need of each substance when we are doing a dilution or an alligation. The next topic we're going to review is concentrations. And concentrations simply mean how much drug is in something. So we want to know the ratio or the percent of drug in the total amount of stuff. And we've talked before about weight, volume, volume. And basically all the difference is whether or not we're using a solid in a solid, a solid in a liquid, or a liquid in a liquid. Keep in mind that it's always going to be out of 100. That's the definition of percent per 100. So let's take a look at our first example. This is a prescription for Pred Forte, and it contains 0.15 grams of prednisolone, so that's our drug, in 15 mils. So that's what the volume is. So it's 0.15 grams in 15 milliliters. So we're trying to find the final concentration. Remember, concentration is always defined as the amount of drug. So in this case, 0.15. So 0.15 grams of drug over total amount of stuff. So when we're putting a solid into a liquid, the total amount of stuff is the liquid. So 15 mils. Now we're ready to do our division, and then we will take that answer and multiply by 100 to change it to a percent. So we put this in our calculator. 0.15 divided by 15. Go ahead and hit your equals button, then do your times 100. When you do that, you will find that the strength of this solution is 1%. So this is a 1% solution. That is the concentration. So it's always amount of drug over total amount of stuff. Again, anytime you're thinking of a solid and a liquid, think about adding sugar to your tea. It dissolves, it goes away, so it doesn't add to the total volume. Here's another example. This time we have 150 mils of active ingredient, and we combine it with 350 mils of normal saline, and we want the final concentration. So the active ingredient, the drug, is 150. Now it's milliliters this time, so we're taking a liquid and we're adding it to another liquid. So our total quantity is going to be adding the 150 and the 350, because again, we're talking about a liquid being added to another liquid. So if we add, I don't know, say you're making some sort of a drink, a mixed drink or something, and you add a liquor to your mixer, your soda, your juice, whatever, that quantity is going to increase. So 150 plus 350 is what's going to go on the bottom down here. So this is going to be out of a total of 500. So my total amount of stuff is 500 milliliters. And again, once we do this division, we're going to always multiply by 100. And again, the reason we're multiplying by 100 is to change it to a percent. So we'll put this in the calculator. 150 divided by 500, hit your equals button, times 100 equals. And in this case, it's going to be 30%. So our final concentration is going to be 30%. All right. The next thing we're going to review is IV calculations. An IV calculation could be a electronic one where we're just doing things like, all we care about is the flow rate, trying to figure out the time, something along those lines. But remember, we've also got those specific formulas for those manual sets where we have drip factors. So it takes a few extra steps if we're talking about a drip factor. So let's take a look at a couple of examples. We have 500 milliliters of D5W, and remember D5W is just the abbreviation for dextrose 5% in water. So this is the volume that we have, and this is the name of the medication or IV infusion in this case. And we're going to make sure that it is administered over 3 hours. So in order to calculate a flow rate, we always want volume over time. So 500 milliliters is my volume. So you always want to make sure your volume is in milliliters if that's what they're asking for. So 500 milliliters, and our time is always going to be in hours. So in this case, 3 hours. And we are ready to put that into the calculator. 500 divided by 3. And I'm going to round to the nearest whole, 167 milliliters per hour. Here's another one. This time we want to figure out how long it's going to take for this to be used up. We want to find the actual time the infusion will stop. The main reason is if the doctor wants us to pick up and do something different, or to start another infusion of the same type when this one ends, we need to know when that time will be. So that's why we want to look for the time and then figure out what time of day we would need to be ready to prepare a new one. So for this one, the order says we're going to have 750 milliliters. LR. LR is the name again of the infusion substance. This stands for lactated ringers. And we're going to be doing it at a rate of 125 milliliters per hour. So we're going to undo this process. So remember before we did volume divided by time. So this time, in order to undo the process, we're going to take the volume, 750, and we're going to divide it by the rate. So we're going to take that 750 and we're going to divide it by that rate of 125 milliliters per hour. Now, we're going to go ahead and stick that in your calculator to figure out the number of hours. Oh, my handwriting is messy. So 750 divided by 125 is going to give me 6 hours. So that's how long it's going to take. Remember, it asked what time are we going to actually stop. So if it started at 11 p.m., we need to go 6 more hours, which will then be 5 a.m. the next morning. So make sure you read the question and answer exactly what they're asking. 6 hours is a correct answer, but it doesn't quite answer the problem completely. We want to make sure we go on and answer about what time it will actually be done. Okay, we will take up the next topic on the next video clip. Thanks a lot.